Hello, everyone. My name is Máté Barabás. I'm a Senior Technical Program Manager, and with me today, I have Bilal Amjad, Principal Cloud Solution Architect, and Karim Setilli, Senior Developer Advocate. Bilal and myself are part of the AVM core team, and Karim is from HashiCorp. And today, we're going to tell you about how you can accelerate your Azure platform journey with Azure Verified Modules. So you have three speakers. You have three major agenda points. So first, I'm going to tell you about Azure Verified Modules, or AVM. I'm going to give you a brief overview, and then I'm going to show you a couple of things here live. Then Bilal is going to tell you about Azure Landing Zones, an overview and a demo. And then Karim is going to tell you about some really cool new features of Terraform, also followed up by a demo. So let's start with Azure Verified Modules, which are the official Microsoft Infra as Code module strategy for Bicep and Terraform. Before we talk about what Azure Verified Modules are, let's start with explaining or understanding what problem AVM modules are solving. So this diagram here explains the typical customer journey. So let's say when a customer starts using the cloud, they start by using the UI. We could jokingly call that ClickOps. Then over time, customers learn that it's not the most efficient way of adapting the cloud, so they start using Infra as Code and DevOps practices. This often leads them to proliferation of code. They realize that they have like 5 different standards of the same exact thing, and they need to decouple and rationalize that code base. At that point, they typically look around on the internet and realize that there are publicly available open source repositories that they could either just draw ideas from or even fully adapt. The challenge, however, is that even if such an open source repository exists in a Microsoft namespace on GitHub, such as github.com/Azure, or github.com/Microsoft, these repositories are often not officially maintained and supported by Microsoft. And then the customer starts adapting these just to learn later that they don't get the type of support and maintenance that they were hoping for. And this is where Azure Verified Modules came to the picture, which is basically supposed to be the one Microsoft solution for Infra as Code modules that everybody can draw from, build upon, and contribute to. All right, let's talk about a couple of key characteristics here. So as I mentioned today, we do support Bicep and Terraform languages, but there is nothing in AVM that would basically prevent us from adding additional Infra as Code languages in the future. The well-architected framework, especially the security and reliability pillars of it, are front and center for us. And our goal here is really to serve everyone with this kind of one Microsoft source of truth approach in order to standardize and accelerate deployments in the cloud, including resources and more complex architectural patterns, and therefore boost the delivery of cloud native or born-in cloud applications, as well as migrated applications that are then progressively improved upon. This solution is not only for our customers, but also for our partners and Microsoft itself as well. So Microsoft IT, for example, is using it to deploy infrastructure globally, as well as we also include it in products such as the AZD or Azure Developer CLI. Let's talk about what exactly AVM modules are then now. So here I have a stack diagram, so let me read it for you bottom up. At the bottom, you have the Azure REST API, or the Azure API layer. On top of it, you have the domain-specific languages, such as Bicep or Terraform. And then AVM sits on top, which means AVM is not a language. It's basically a library of templates written in Bicep or Terraform languages. Why do we call them modules then, if they are templates? The reason behind that is that every single template is published in the corresponding public registry. So the Bicep modules are published in the Bicep public registry, and the Terraform modules are published in the HashiCorp Terraform registry. So when we zoom into that bigger green box there, you see that we have 3 categories of modules. The first category is what we call resource modules, which are the low-level atomic building blocks. Those are like typically one-to-one associated to Azure resources. They wrap what we call all the bells and whistles that come together with a resource. So for example, Key Vault has a resource module, or storage account has a resource module, or a virtual machine has a resource module. Pattern modules, on the other hand, are the more complex architectural patterns or workloads or accelerators, like solution accelerators or landing zone accelerators, as I have it here in the examples. So you could think of those as the Kubernetes Services Landing Zone Accelerator or the Azure Virtual Desktop Landing Zone Accelerator or any third-party solution or any custom solution can be published as a pattern module in Azure Verified Modules. And then the last category, utility modules, those are like small helper functions or sidecar functions, basically things that we would otherwise need to repeat across every single module. We just put those into a utility module and reference them. I need to mention that this entire program is absolutely available online, open source, and absolutely 100% free for everyone to use. All right, let's zoom in one more notch into this green bubble. So normally, when you leverage Azure resources and you try to build infrastructure as code templates, you operate in the top layer, solution templates layer, right? So as you see here, AVM basically is injected in the middle, so between your solution template and Azure resources. And this diagram is here to show you what are the relationships and mappings. So for example, between an Azure resource and an Azure resource module, typically there is a one-to-one mapping. But sometimes, such as in case of the virtual machine module, we do include not only the virtual machine itself, but also extensions, data disks, network interface cards, etc. And then these resource modules can and should be used in pattern modules. And then ultimately, a solution template that you as an end user basically build and maintain can and should reference these pattern modules and resource modules. And in case there is none available that fits your needs, then you can still, of course, directly reference Azure resources. OK, this is just a quick comparison for you to better understand how AVM compares with other libraries. In AVM, we have a lot of strict rules and standards. We call them specifications that are actually also enforced by our automation and test environment. And we do have this module classification that I just explained, so resource, pattern, and utility modules. And the most important difference between AVM and other libraries is that in AVM, especially the resource modules, are very generic and flexible. So if you check out the source code of such resource module, you would find that even simple resources such as Key Vault, they have many hundred lines of code. Why is that so? Because every resource module has a lot of complexity inside. In exchange, when you interact with them, you can deploy them through defining parameters. So let me give you an example. In other libraries, you might find a virtual machine module, let's say a Windows virtual machine module, as a template, as an example. And then you can find another one, which is a Windows VM, let's say with 2 data disks. And then you can find a third one that is a Windows VM with domain join extension. The problem is, typically, that when you need to stitch together these capabilities, let's say you need a Windows VM with domain join and multiple data disks, then you won't find such an example. And then you need to stitch together the pieces, so you will end up testing, building, testing, troubleshooting, etc. In contrast with that, in AVM, we have a single virtual machine module that is flexible, so it's full of conditional expressions and complex functions. And you can interact with that module through complex parameter objects without touching the source code of the module itself. All right, demo time. So my demo will have 2 parts. In the first part, I'm going to show you what you can find on the AVM website. And in the second part, I'm going to show you what the developer experience is like when it comes to editing by-step templates, like a solution template. So let's start with the website. The website is available under ak.ms/avm. And when you go there, you basically are welcomed with a short YouTube video here, which is giving you a similar pitch such as the one I'm giving right now. So in case you want to show AVM to your colleagues, it's probably the best place to start. Now let's take a look on the left here at the menu structure. So after a short overview and introductory section, we have module indexes. I'm going to come back to those in a moment. And then down here, we have a usage guide. Currently, we have 2 major chapters. So this is under development. Please expect more to come very shortly. So Quick Start is literally just a simple exercise to get your hands dirty in case you want to try out Azure Verified Modules. And then Solution Development is like a more complex scenario which talks you through the points in terms of like what exactly you need to do when you want to build your own solution template, like how do you put pieces together and cross-reference them, etc. Specifications and definitions. This section holds all the information about those rules that I mentioned earlier that make every module look and feel the same. Help and support includes our support statement. It explains how you can submit a support ticket over GitHub in case you find something missing, and has a bunch of other information available. Contribution section is about when you, as I mentioned, it's open source, so when you want to come back and say, hey, I actually have some code here that I believe others could make use of, that section describes in depth like what has to be done there to make that possible. And then down here we have a resources section. So we do run our own monthly community calls. Those are recorded, uploaded to YouTube. You can find the previous one there. And then we have an FAQ here. Whenever we receive questions, we try to answer those under that section. So it's definitely worth it to check it out. All right, so I did promise to come back to the module indexes section here. So let me do that. So no surprise, we have Bicep and Terraform, and under both languages, we have these three classifications, resource, pattern, and utility. So if you take a look at the first column, you see how many of each category we have published. So if you add up the numbers, you see that we have roughly 200 Bicep modules and a little over 100 Terraform modules available today. Now, this is not intentional. This is only so because of historic reasons. So we are kind of playing sort of a catch-up game here in case of Terraform. But we are treating them equal. The investment is going into both equally, so we will get there on the Terraform side as well. So let me show you what it looks like when, let's say, I click on the Bicep resource modules area here. I have a long list of resource modules available. Again, 156 resource modules. So let's say I want to check out Key Vault. So let me just use the search feature of the browser here. And then I can click on the link which leads me to the source code. So in here, there is going to be like a detailed documentation on all the resource types that are implemented in this Key Vault. So you see that it's not just the Key Vault itself as a resource, but also its child resources such as keys, secrets, endpoints, and other things such as diagnostic settings and private endpoints and a bunch of other things. Then you have a couple of examples here. So example one is typically the simple-most example. And then the last one, we typically have 4, 5, 6. The last one is the most complex one. So the first one is typically only a few lines of code. Like the idea is that we only make like the bare minimum mandatory, and we do provide like smart standards. We also attach like a Bicep parameter file and a JSON parameter file. And if this was a Terraform module, you would obviously see all the sample code in Terraform as well. And then down here, we have a lot of details about all the parameters, especially the complex ones. I'm going to show you an example later, but everything is documented and described down here. Let me move on to the second part of the demo, which will be here in VS Code. So for the sake of this one, let's say I'm part of a DevOps team, and I was just asked to deploy a Key Vault so that my team can store some secrets in a secure way. I just heard about AVM, and I already know Bicep. So let's take a look what this experience would look like. So I need to use the module keyword, and then I need to provide here like a symbolic name for this Key Vault resource module. And then you see that IntelliSense gets triggered, and there is a br/public entry here that stands for the Bicep registry and the public instance of that Bicep registry. So if I tap complete, you will see that there is a dropdown here that includes those roughly 200 Azure Verified modules that we have published. And you may notice that all of the items here start with AVM. That's because there is nothing else in the Bicep public registry than AVM modules. And that's no surprise because it's Microsoft standard. So let's say, again, I want to deploy a Key Vault. So let me just type in Key Vault and then use tab completion here. So this shows me all the available versions. I'm going to pick the latest one. And then knowing the syntax, I'm just going to let IntelliSense to complete the bare minimum. So I could deploy this just by providing a name. Now let's move on and see what other parameters are available. So there are obviously simple ones. I could enable purge protection. Two, I could enable, let's say, soft delete, and a bunch of other stuff. But that's not what AVM is good for, right? So let's look into the real stuff. We have diagnostics settings. Now, normally, if you have ever done this through infrastructure as code, you know that the diagnostics configuration in Bicep is a resource on its own. So you would need to look up like what that structure looks like in the documentation, and then paste that code here, and then test and troubleshoot. Now, here, you can just say, I want to send all my diagnostics logs into a log analytics workspace. So I just provide the workspace ID, and that's it. So it's like much less lines of code. Let me give you another example how AVM makes your life easier here. So we have private endpoints. Very similar story. So normally, using private endpoints, that's an entire resource. It has like 15, 20 lines of code. Here, you can just provide a subnet resource ID, and that's it. And then my personal favorite is role assignments. So let's say I have to provide my team members access to this Key Vault instance. So if you have ever done this with infra as code, you know that this is the point where you are supposed to stop, go and read documentation, and then look up what GUID stands for, let's say, an owner or a contributor. Now here, let me show you how AVM helps you. So if you hover over this symbolic name that we provided, there is a view documentation link. If I click on that, it leads me to the same page that I just showed you around. And then you can go to the parameters section and then look for that role assignments input parameter that we were defining. And then the module actually has all the most commonly used resource type related role assignments or role definitions pre-baked. So that means that instead of using ugly GUIDs, you can just say, I want to give my team members Key Vault contributor access, or crypto officer, or whatever. You get the idea here. And then there is one last thing I want to show you as part of this demo, which is that if I right-click here, I can also just say go to definition. So if you take a look, I mean, this is very professionally written, so there are some cool tricks that you can learn about here in terms of the capabilities of the Bicep language and conditional expressions, etc. But what I want to show you is that even for something as simple as Key Vault, we have like a file here that's 600 lines of code. So this is the extra burden that AVM takes off your shoulders if you are using it. All right, let's get back to my presentation. I have one more slide here. So when you want to use AVM, you don't want to use it in vacuum, right? In the production-grade environment, you are supposed to have Azure Landing Zones. Azure Landing Zones is the official Microsoft way of deploying workloads in production. So we have platform landing zones and application landing zones. And I'm inviting Bilal to tell you more about this topic.
Hi, everyone. So my name is Bilal, and I'm a cloud solution architect with Microsoft. I'll be taking over this journey that Monte has kind of started us on. It's about how you use Azure Verified Modules. So Azure Landing Zones, as you might know, is basically our reference architecture and our reference implementation for enabling an Azure environment end-to-end. The platform part, and then the applications which you bring onto that platform. Now, for something that's as important as setting up an end-to-end cloud environment through Azure Landing Zones, we're going to be helping you kind of understand how you can use Azure Verified Modules for that, focusing particularly on the platform part. Once you've got the platform up and running, on top of the platform, you can basically bring on your applications. So for platform landing zones, for you to be able to set them up, we've made Azure Verified Modules available that you can leverage and set up your platform. The Terraform modules are currently available, and I'll show you them when we get to the demo. The Bicep ones are currently in works. So for those of the customers that are using Terraform, you can basically leverage that. So just giving you a bit more detail on the Terraform part. So on the Terraform side, what you will see is we've got, when you deploy landing zones, you start with deploying your management groups. On your management groups, you deploy your Azure policies. So you can see in the top left-hand corner, the module that we use for that. On the top right-hand corner, then you'll see the management resources that we deploy, which includes the log analytics workspace, the data collection rules, the managed identities. That's your management part. And then at the bottom, you see one of the most heaviest components of setting up a platform in the cloud is connectivity. So you've got two options over there. You can either go hub and spoke topology or virtual WAN, Azure Virtual WAN topology. So again, you'll see underneath them, you'll see the pattern modules that we have referenced and the resources that are deployed as part of that. So these Azure Verified modules as a collection kind of help you deploy your platform landing zones in Azure. Now, I think the key thing here is you've got the code through the modules that we are providing you, but now you need to automate this end-to-end. You need to put this code in some kind of version control system where you've got a Git repository. On top of that in that version control system, on top of that code, you want to set up your pipelines, set up CI/CD, right? And do this end-to-end, where whenever you've got code in your Git repository, that kicks off a deployment on Azure and deploys your resources. How would you achieve that through without having to do a lot of work by yourself? You can use something that we've introduced. It's called the IAC accelerator. So infrastructure as a code accelerator helps you, number one, bootstrap your bicep or Terraform implementation. It sets up a CI/CD in your GitHub or Azure DevOps, gives you a composable and configurable platform landing zone. We recommend it for most of the customers because it aims at 80% of the scenarios which we've seen out there. And then last but not the least, it's got an easy to follow process, which I'll guide you when we get to the demo. Now, this slide is particularly important because in the demo, I'm going to be taking you through some of the concepts which you see on this slide. We're going to talk about components. So component-wise, first of all, documentation. So we'll walk you through the user guide that tells you the details around how to leverage Azure, how to leverage this accelerator. Then we'll talk about platform landing zones. After documentation, you've got configuration files. Two key configuration files, one for your Bootstrap, which is basically a YAML file. I'll show that file to you. That file is particularly important for setting up your Bootstrap. Number two is your TF-vars file. That file is important for setting up your platform landing zones. So all your configuration details like which region am I deploying in, which topology am I choosing, what features am I turning on or off, all of that go into that platform landing zone file that you see. Then basically you've got your Azure ALZ PowerShell module. So the ALZ PowerShell module takes your files, the two configuration files as input, and that's the module that is responsible for setting up your Bootstrap in your version control system. So let's talk about the phases on the right-hand side. So the first phase, phase 0, is planning. So you start with planning what kind of bootstrapping are you going to do and what kind of platform landing zones you're going to set up. And I'll show this to you in the demo. Phase 1 after that is basically your prerequisites, where you figure out what kind of identity setup you're going to do and what are your subscriptions in which you're going to do this deployment. Phase 2 after that is Bootstrap. So in Bootstrap, whether you've chosen Azure, GitHub or Azure DevOps, that's where your version control system gets configured with the right configurations, with the right repos, the right identity setup. And your Azure also gets initiated with resources that are required by that Bootstrap. So for example, a storage account for hosting the Terraform state file, and your identities for plan and apply. And then last but not the least, once that bootstrapping is done, then you run your pipeline or your GitHub action to basically do the deployment. So that's about the IAC accelerator. Now, once you've got your now going into a bit more details in terms of Bootstrap. So the Bootstrap provides you with an Azure setup that you see here on the left. So once you run the Bootstrap, it's going to create identities for your plan and apply. These are, as security best practices go, these are basically user-assigned managed identities with federated credentials for your plan and apply. Again, as a security best practice, we recommend you put your state file, your Terraform state file in a storage account and secure that with private networking. So that gets set up for you without you having to do that. And then depending upon whether you're using Azure DevOps or GitHub, your agents and runners also get set up with a container registry and container instances. On the version control side, whether you've chosen GitHub or Azure DevOps, we set up your repository with the branch policy. We set up your environments for plan and apply. We set up your group or teams with the approvers that you select who can approve a plan and apply. We set up your pipelines or actions for your CI/CD, and then your variable sets or repository variables. Along with that, your agent pool or runner group also gets configured with this. Something specific to Azure DevOps are the service connections. So that step is also taken care for you by the ISE accelerator. So all of this configuration that you see on this screen will happen through just one single command, which I will show you. And you basically don't have to do all of these configurations manually. So once you've done your bootstrap, two key things that you'll have to do after that is choose your scenario. So what kind of scenario are you deploying? So are you deploying single region, multi-region? Are you deploying hub and spoke or virtual WAN? Are you deploying Azure firewall or a third-party firewall? Based on those scenarios, you'll select a scenario, or maybe you're just deploying the management groups, the policies, and the management resources only. So you'll choose your scenario, so that's one of the first things you'll do. Once you've chosen your scenario, every customer wants to kind of customize it. We're not saying that this is that you won't need to customize this. You would need to customize this. Like, for example, one of the popular asks is that, hey, I want to use my resource naming convention. So based on your option, customization option, you'll choose that customization option and make those customizations. For example, I'll show you the one, number 3 here, which is we turn on the DDoS plan by default. But if you want to turn it off, how would you go about doing that? So I'll show you how you'll do that. So you've got your platform ready. Once your platform is ready and deployed, any platform out there on the cloud environment is no good without any applications or workload deployed on it. So as your business, as your organization wants to bring in their platform, their applications and their workloads, how would you go about doing that? And you want also that part to be automated. You don't want that part to be manually done, right? So for that, now we're heading from platform landing zones into application landing zones. So in application landing zones, a team comes up to you and says, hey, we want to put our web application up into the cloud on the platform that you've established. So that can start from creating your subscriptions, setting up connectivity for them, hooking up their code repository, setting up security, observability, and management for them, the CI/CD that needs to be done with Identity Federation, any identity access packages that need to be set up, giving them a development environment, and then last but not the least, deploying the resources on top of which they will bring in their application. So maybe you'll deploy some basic infrastructure for them, which includes a virtual network, which includes a few VMs, and on that, they will bring in their application. So there's a whole list of work that needs to happen before an application team is ready to bring in an application. And we would ideally want all that part to be automated also. So for that, we use something called landing zone vending, and I'll discuss that in the demo in a bit also. So end to end, what does the journey really look like for a customer today on Azure in terms of infrastructure as a code, automation, and in general platform engineering and deployment? So the journey basically starts with creating your subscriptions for your platform in which you set up your connectivity, identity, and management resources. Basically resources which are central and application or workload agnostic. These are the resources which will be used by not just one application or workload. These will be used by a number of applications and workloads. Then once you've got your subscriptions, you create your platform within those subscriptions. Once you've created your platform, then you head over into landing zone vending, where you establish a process which basically vends out subscriptions to application teams in which they can bring in their applications. And then last but not the least, the application teams can deploy their workloads using either one of the accelerators we have, like it's listed over here at the bottom, or you can use, as you can see at the bottom, we've got Azure Verified module. throughout this whole process, you can use any of the Azure, you can use a combination of the Azure Verified modules to build your own journey or supplement your own journey as you would like to using the modules that we're providing you. So the Azure Verified modules are basically can be plugged into each stage that you basically see here. So I'm going to take us into a demo and kind of into a collective challenge where our management has asked us to enable an end-to-end Azure environment in days, not weeks, and using infrastructure as a code. So we need to figure out how we'll do that. So I'm going to navigate this as if I am a customer, and so that if you're watching this demo live or in the recording, you can basically follow along as I go through this. Okay, so the first starting point would be for us, Azure Landing Zones. The way you can get to Azure Landing Zones documentation that you see here is just go aka.ms/alz. That should get you to Azure Landing Zones. Once you land here, you'll start seeing some of the concepts that I already talked about. So you'll see the architecture that we talked about, which is the reference architecture for enabling an Azure environment. You'll see the concept of platform landing zones and application landing zones that I talked about. Then if you kind of scroll down below, you'll also see the Azure Verified modules being called out here if you're doing infrastructure as a code deployment of your platform landing zones. So here, if I click the link Bicep and Terraform deployment options, that takes me to this page, which basically tells me the options that I have available for deploying a standard deployment of Azure Landing Zones. So we've got Portal, Bicep, and Terraform. I'm interested in Terraform for the purpose of this demo. If I go through this link, it's going to take me to the technical documentation on how Azure Landing Zones can be deployed through Terraform. And like I called out before, you can see here the modules that we use for deploying platform landing zones. So this is the list of modules that we use. And if you click, let's say I'll click the very first one, Azure ALZ Core. The ALZ Core will take you to HashiCorp registry, where you'll find our module in the registry. And if you want to look at the source code, you can also then click the link, and that should take you to the GitHub repo, where you will basically find our source code available and its documentation so that you can go through and understand how this is deploying, what part of the platform is this deploying. Now, I'm going to take a step back. As I said, these are the modules. You've got the modules, but I want to give you an end-to-end experience on this. How would you do that? So you'll basically go by leveraging the user guide that's available at the Azure Landing Zone technical documentation that you see here. Phase 0 is planning. So you're planning for two key things here. You're planning for your Bootstrap, so the Bootstrap environment that you will set up, and you're planning for your platform landing zones. A visual representation of that should be this diagram, and let me zoom in here for us, which should give you a better understanding on how this should look like. So basically, as you can see here, on the left-hand side is the Bootstrap part. This is what gets set up with the Bootstrap configuration. On the right-hand side is your platform landing zone part. So what you're going to do is that you're going to first download a checklist, which is an Excel checklist, which helps you go through a list of decisions that you need to take to first do some Bootstrap decisions. So something as simple as, OK, which ISC language are you going to use? Is it Terraform or is it Bicep? Which version control system are you going to use? Is it GitHub, Azure DevOps, or maybe it's a third version control system? So you kind of make these decisions first for your Bootstrap part. Once you've made those decisions for your Bootstrap part, then you head into making decisions for your platform part. So for your platform, if you remember, I talked about the scenarios and the options. So you choose a scenario. So you could choose, for example, the scenario I've chosen is, I'm going to deploy a multi-region hub and spoke virtual network with Azure Firewall. That's my scenario. And you can see here in the left menu, you can see the other scenarios that you can choose from. And you'll see a TF-vars file as a sample available over here. This file we're going to use in a bit, and I'm going to show you how we're going to use that to do our configurations. Once you've chosen your scenario, you choose your options for any customizations, if you want to make any customizations. So in the left-hand menu, you can see the options that we have available, and you basically choose, like if you want to customize your naming conventions, you can choose them from here. And in my case, I'm going to turn off the DDoS protection plan, so you can see it's telling me where exactly do I need to make those updates in my TF-vars file to basically turn off my DDoS plan. So here's the TF-vars file that I was just talking about, and I know this is small, so I'll take you also into Visual Studio Code to talk about this. But you can see here what am I doing essentially here. I'm essentially providing my platform landing zone configurations, which will deploy my platform part. So just as a reminder, the platform part is what you see here on the right. And then this other file, which was this YAML file, which is for my Bootstrap, what I'm providing here in this Bootstrap file is my Bootstrap configuration, which will basically deploy what you see essentially over here. So on the left-hand side. So that deploys the left-hand part. So let me kind of go back. And so once you've got these two files, the next thing you want to do is that you're going to open up your Visual Studio Code and make have both of your files ready at hand. Like for example, you can see me indicating that I'm doing multi-region, which means 2 regions. So I'm saying do a deployment in West US 2 and East US 2. I'm going to provide my subscription details over here, my management group and subscription details, which I'm using over here, and customize this file based on my Bootstrap requirements. And then the TF-vars file is for my platform part, and this file is basically responsible for deploying the platform. And you can see here, based on the option that I chose to disable a few things, like disabling DDoS plan, you can see I've already taken, following that guidance, I've basically commented out the DDoS over here based on that guidance. So that will ensure that my DDoS is disabled. Once I've done that, the next step for me is to now get ready to bootstrap. So I'm going to install the ALZ PowerShell module. If you remember, I showed that in the diagram. And that PowerShell module is going to help me set up my bootstrap. So I'll start with that by basically installing the PowerShell module. Once I've done that, then the next step for me is to create a directory as you see here. This directory structure gets created by the commands that you see up here, which are basically referencing those 2 configuration files, the Bootstrap configuration YAML file and the platform configuration TF-vars file. And once I'm ready with my configuration, the thing that I need to do is that I just need to go ahead and run this command that you see here in my Visual Studio Code. And once I run this command, this is going to set up this part on the left-hand side that you see here. And this will basically set up my repo, set up my Azure environment with the Bootstrap configuration that I need. It hasn't deployed the platform part that you see on the right. It hasn't deployed that yet. So it sets up my Bootstrap CI/CD part. And the way I can show you that is, so we'll come to run in a bit. Let me take you to my GitHub organization. So I'm in my GitHub organization. Once I run that command that I showed you on Visual Studio, you'll see a couple of repos created here. One of the repos, the ALZ management template repos, has my CI/CD template files. So these are the continuous integration, continuous delivery, GitHub action files that are being used. And then the other repo is basically my repo for where I have my Terraform code, which will deploy my platform. So it will deploy a hub in West US 2, a hub in East US 2, the regions that I've provided. And you can look at the code through what you see here in these TF files. Now, for deployment, what I will do is I will run this deployment through what you see here in phase 3. If you're doing Azure DevOps, you run the pipeline. If you're doing GitHub, you basically run GitHub Actions. And the way I'm going to do that is that I'm going to go here and go to Actions. And you will see that I can go ahead and run my continuous delivery action. And if I run this workflow now, this workflow will deploy my platform in Azure. And that's that part here that you see here on the platform landing zone side. So now my platform will get set up based on the configuration of the Terraform files that I have. And let me go back here and walk you through. Once you've got your platform set up and running, you can go into Azure, log in. Azure Landing Zone starts from a management group point of view. So at the management group level, you can expand and see all the management groups that it has created. You can see that the subscriptions have been placed in the right order. On these management groups, you'll find the policies that Azure Landing Zones applies, also applied on them. You'll find the resources that I said that, as part of my TF-vars file to deploy. You'll find those resources also deployed. So if I go here, you'll find all the connectivity resources that I wanted to be deployed, also deployed. So you can see the firewalls, you can see the firewall policy, you can see the virtual networks, the NSGs. All of this has been deployed all through the TF configuration that I've provided. So that kind of takes care of my platform part. Now I'm interested in my applications part. Application teams want to come in and get their deployments done. For them, what I'm going to do is that I'm going to leverage something called subscription vending. So we have subscription vending available for both Bicep and Terraform. Let's talk about Terraform. You can leverage the module that's available here. This is again available in Terraform registry. You can also have a look through the code that's available in our GitHub repo and configure subscription vending. Once you've done your subscription vending, the last mile of this journey is deploying workloads. So maybe you've got Azure Virtual Desktop team coming up to you and saying, hey, you've got the platform set up, we want to deploy Azure Virtual Desktop now on this platform. So in Cloud Adoption Framework, you'll find our different scenarios where we provide you with accelerators. One of the accelerators is for virtual desktops, and if you go there, you can see under preparing environment implementation options, you will see the accelerator options that we provide you, and basically leveraging this, you can deploy this environment that you see here. And that's available again in Portal, Terraform, and in Bicep. And you'll find the modules for deploying this on Azure Verified Modules again. So hopefully this helps you. And with that, I'm going to hand over to Kareem, who's going to walk us through how you can package all of this deployment up into a concept called stacks in infrastructure as a code. So if you want to do this across dev, test, prod, across multi-region, how do you scale that? So I'm going to hand over to Kareem. And thank you.
Beautiful. Take a second to just think about this real quick. Let me actually switch back to our slides here to make sure that works out. Here we go. We have deployed so much right now, right? Landing zone, check. Count vending, arguably the hardest part of it all, check. The thing that really makes me happy, everything is codified. And that's really what you want, right? At this point, we're practically done. Oh, wait, there was this one thing that Bilal mentioned. Is like, well, no application, no workloads. Not there yet. All right, we'll get into that. We'll fix that. We've got about 15, 16 minutes left. We're going to do this. Classic way of doing this, somebody goes into the portal, clicks through everything, and then you import it into Terraform, right? Terraform import or more modern ways of doing it, actually using the import statement. It's almost the future. No, it's not the future. You shouldn't have to import stuff because you should just start out codified, and then things get a lot simpler. So let me ask you this. Have you ever found yourself in a situation in your company or in the Terraform work you do where you build custom tooling, custom wrappers around Terraform, something that has to happen? You don't have to raise your hand because I know, like nobody wants to self-identify as the person that has done that and wasted engineering effort on that. But I will tell you that I have, and I know many people that have as well. Problem with that approach is often that it doesn't scale from one company to the other, doesn't scale from one environment to the other. There's a new team that got onboarded, maybe you hired a company, they come in with their own methodologies, doesn't work. And the worst part is it never works at scale. Always works for one account, never works for 2, 20, 50, 100. And that's a problem. So let's take a step back. Let's look at standard Terraform deployment, see what we can do to make it a little bit more reliable, the deployment phase, make it much more scalable, and not break our operations team and overload them with a lot of extra work. Start with a Key Vault and some cognitive services that we're running, standard Terraform module, well documented, of course, everything. And all of this evolved from just being a standalone resource into modules that we can reuse, and we're super proud of them, right? And then, well, we had second environment, we started on dev, we've got prod. We had this one engineer that made a little mistake, so now the CISO requires us to add in the test environment, and so now we're at the complexity of 3. Now we want to deal with customers around the world, so we have to deal with different privacy regulations and everything, and all of a sudden, all of this becomes a problem of 3 environments per region that you're deploying in or per legal system that you're deploying in, and things get a little bit harder. In fact, they get so much harder that we're actually switching accounts, switching regions, doing everything that has to happen there. We added in ACR because we have to store our models for cognitive services in region-specific locations to make sure we run some of our workloads on AKS, and things keep growing. Our tiny Terraform modules are no longer tiny, nor are they easy to deploy. But the best part about all of this is that we now have the foundational parts of what will eventually become a Terraform Stacks deployment. On the left side, you'll see our components, so AKS and ACR, for example, and the OpenAI service or cognitive service, and then our different stacks. And you might be looking at this and it's like, well, this is fairly simple. Like, well, that's because it's supposed to be. So take our input config, add a couple of stacks on top of it, which is really maybe 25, 50 lines of code. Now, I'm making this up, despite working in marketing. It's a real number. We had some fun behind the scenes, as we're building the session, just stackifying different deployments, and it generally took no more than half an hour. I'm not going to say it's always going to take half an hour, but it is a really quick approach of getting this into stacks. And that's what we want. Terraform Stacks basically gives you a native way, native to Terraform, so a way that you don't need to maintain, to simplify multi-tier, multi-region, multi-account even, infrastructure deployments. And what it really comes down to, as an operations engineer, the thing I like is it allows me to bring complex deployment logic without having to maintain another deployment server, without increasing infrastructure complexity, in just a system that works. So let's have a look at some code. If you've ever written Terraform, these lines will look familiar. It's because Terraform Stacks uses the same configuration. It's all HCL-based. And you'll notice a couple things. We're specifying version ranges, 4.29 for the Azure RM provider, released last week Thursday. Great update, get that, and make sure we're not automatically upgrading to the next major version. Because we want to be lazy engineers, we don't want to be engineers that get paged in the middle of the night. We want to make sure our code is safe and secure. Just to find a little bit in our provider config. In our case, well, you might recognize a few things here. Obviously, environment, public. We're not doing anything federal today. A couple of Key Vault settings, because we want to make sure anything we do in our cognitive services is actually properly secured. And you might notice a new one, a for each in there. We'll get into that a little bit later. Before that, though, comes the fun part. if you are vending accounts, how are you going to deal with all the credentials and everything else that goes in there? OIDC is really the answer to everything for this, and that's what's beautiful about it. We make sure you get an identity token through the Stacks deployment flow. In that way, we can specify roles that are super granular. We can specify different roles for our plan phase. We can specify different roles for our apply phase, making sure that even if something goes wrong in the plan phase, because the role does not have certain permissions, it can't actually delete, or the service principal can't actually delete anything. A couple more things that we'll add in, our client ID, of course, and our ephemeral identity token. Write once, consume once, consume as often as this token is needed, and best part, not visible to me. Anytime your operators don't see the token they're working on is one more checkbox that your auditors can just give you without you having to get stressed out. And then comes the part that you already have, wrapping your application in a component, putting a few variables in our case, what we want to specify is a location. Obviously, there's about 25 more, but they're not super relevant for this showcase. We're pushing in the providers that we need, again, with an option to specify specific providers for specific endpoints. We could say, maybe we want to have the random provider that's HSM backed because we want hardware-based randomness instead of software-based randomness. So there's a couple of options that we can do and use. Then put the whole thing into the deployment logic, where we're really just doing one thing really crucially, and that's the top part, getting an identity token through our OIDC workflow, making sure we can provide that. We obviously provided a subscription and tenant ID, and with that, we're almost done, except we now can define deploy behavior. So for certain operations, I know none of you would ever do this, but I've definitely worked with colleagues that will auto-approve every Terraform change. And I hear the chuckle, right? We recognize those colleagues. It happens. It's a real thing. And sometimes an auto-approve is good. You know, like for a plan operation, I am totally fine of you auto-approving the deployment, the plan, phase, plan operation, not the plan deployment. If it's not a plan, then, well, we want to make sure, you know, like we push out the notification to our operators in the system to say this needs human intervention. Similarly, we want to make sure nothing gets removed. If something gets removed, then that's probably something we want to be looking at, because resources that get removed were usually resources that were deployed for a reason. Even if you're just cleaning up your own mistakes or somebody else's, there's still a reason to know what's happening. And then my personal favorite, Stacks deployment orchestration rules can go down into specific components and say, if there's a change in, for example, the DNS component, then we're not going to automatically apply. One simple reason, imagine you have the perfect deployment, right? Your AKS gets upgraded, you spin up all the pods, everything works, but you somehow manage to mess up the DNS zone. Doesn't matter if everything is running because nobody can connect to it. So in that case, have a deployment rule, orchestration rule that makes sure that that is no longer a problem. Oh, and to show you how this all works, let me quickly switch to my laptop. It's beautiful when things work the first time. So just to show you one of the subscriptions that we're working in, so WestUS 3, clearly the best region that we could have picked. I mean, even the people on the outside are loving it. We'll look at our project here. And you'll notice that in the UI, we now have a new option called Stacks. And so if we go into Stacks here, you'll see that, ignore the errors for loading something. We rolled out a new configuration about 2 hours ago at this point. It is actually rolled out, but I'm purposely not refreshing the page to give you this overview. And if I click here and do a quick view, it is now marked as indeed applying, and you'll see all the resources that we're generating. And of course, we're going to reload exactly at this point. I love it. Give me 1 second while we deal with that and switch to a different tab. There we go. So, same type of deployment. This one is a little bit older. This was a full-on AKS stack. And I think the other one is back. Yes. There we go. So, back to our original, because that was the one that we had for today. We've got a deployment plan for development, which received a new configuration through VCS changes that automatically get monitored. And with that, we know that we've got everything that we need. You might be thinking, it's like, well, this was the quickest Stacks demo that I've seen in my life. And that is absolutely on purpose. Stacks does not try to get in the way, tries to get out of the way, while giving you a few extra options like orchestration rules. And that is pretty much all you need to get your application deployed. Let me see if the tab, okay. It was going to time out at one point. Luckily, it was at the end of the demo. So we'll switch back here, get in here, hopefully. Yes. We can see that our deployments have all rolled out. We can see this was only the application for the application component, so that works. And with that, we've got a working system, which means it is time to hand it back to Mate to talk a little more about this. Thank you.
Thank you, Karim. All right, let's wrap it up then. So today, you learned about Azure Verified Modules, which is the Microsoft Infra as Code module strategy for Bicep and Terraform. You also learned about Azure Landing Zones, which is the Microsoft way of deploying infrastructure as well as applications into a production-grade environment. And you learned about Terraform stacks. I recommend you taking a photo of this slide here, as we have the most important links listed. So the AVM website is ak.ms/avm. For Azure Landing Zones, we have ALZ and ALZ/TechDocs. And we do have like an aggregator website here just set up for this event. So that's hashi.co/build25-brk196. And then we have a couple of related sessions throughout this week. The first one happened earlier today, but it's recorded. So go and check that out. There is one on Wednesday. And then there is one as a pre-recorded session that HashiCorp did. And then HashiCorp is present with a booth here in the hub area, numbered FB211. And there is a registration-only event also this week on the Microsoft campus, which will take place on Thursday. So if you're interested in that, please go and check out that HashiCorp link that I have here at the bottom left corner. And then the next slide is the other one that I recommend you taking a photo of. So here we have ak.ms/build25/brk196, which is the session page. So all the links that I showed you on the previous slide are also listed, as well as some additional resources and related sessions. And with that, on behalf of the Azure Verified Modules team and the ALZ team and HashiCorp, I would like to thank you for your attention.